In this video, we're going to look at an example of doing trigonometric substitution with the tangent function. So we're being asked to be able to integrate the function x cubed over square root of x squared plus 4 dx. So we notice that we've got variable squared plus constant. So that's what's telling us that we really want to do the tangent substitution, because we know that tangent squared theta plus 1 equals secant squared theta. However, since we have a 4 here, we need to be able to show for whatever we plug in for x here, I need to be able to factor out a 4 after I square it. So I don't want just a tangent here, I want a 2 tangent theta, because when I square the 2 I'll get a 4, and then I'll be able to factor the 4 out of each term. So we're going to let x equal 2 tangent theta. Our dx will be 2 secant squared theta d theta. So now we plug in the 2 tangent theta for x wherever we see it, and then we're going to plug in 2 secant squared theta d theta in for the dx. When we cube 2 tangent theta, we get 8 tangent cubed theta. When we square tangent theta, we get the 2 tangent theta, we get 4 tangent squared theta. So under the radical, we've got square root of 4 tangent squared theta plus 4, and like I mentioned before, when we started all of this substitution, we can factor out the 4 now, which leaves us with a tangent squared plus 1 in parentheses underneath that radical. As far as the other housekeeping pieces go, we've got an 8 and a 2 on top, so we can pull the 16 out in front. And we're still left with secant squared theta and a tangent cubed theta on the top as well. So then we replace the tangent squared theta plus 1 with secant squared theta. So now under the radical, we have 4 secant squared theta. And taking the square root, we get 2 secant theta. Remember, we don't need to worry about absolute value bars here, because for argument's sake, we're going to assume that our theta ends up being in the first quadrant, so that all of our trig functions that we're using will all be positive. All right, so if we do a little bit more housekeeping now that we've simplified the denominator to secant theta, I can pull the 2 out in front that's in the denominator. That changes the constant out in front to an 8. We get a secant that also cancels, so we can get a secant theta just there times the tangent cubed. We now notice that we have an odd power of tangent. So we're going to pull off a secant theta and a tangent theta for du. And we're going to convert the rest of the tangents over to secant. When we pull off the 1 tangent, we're left with tangent squared. We can replace that with secant squared plus 1. So this integral at the bottom, we've got 8 times secant squared theta minus 1 times secant theta tangent theta d theta. So now we'll let u equal secant theta. du is secant theta tangent theta d theta. So when we make the u substitution, we now have 8 times the integral of u squared minus 1 du. This is a binomial that's easy to integrate. We get 1/3 u cubed minus u for its antiderivative. We still have the 8 that's out in front of the integral, so we need to multiply that by the antiderivative, and then of course don't forget the plus c on the end. Substituting back in what we have for u, we get 8/3 secant cubed theta minus 8 secant theta plus c. Now we need to go back and change from thetas to x's. So remember, the original substitution was x equals 2 tangent theta, or we can think of that as tangent theta equals x over 2. That means we can draw a right triangle, put a theta as one of our angles. The opposite side we can label as x. The adjacent side we can label as 2. Pythagorean theorem gives us square root of x squared plus 4 for the hypotenuse. And now we're ready to write our final answer for our antiderivative. We've got secant cubed of theta. Secant is hypotenuse over adjacent. We cube that. So we'll get x squared plus 4 to the 3/2 power. And when we cube the 2 that'll be on bottom, we get 8, which will cancel with the 8 on top. So that's why we just have it all over 3 here. And then likewise, when we plug in for secant of theta, we'll get square root of x plus 4 over 2 for secant of theta. So the 2 will go into the 8 4 times, and so that's where the minus 4 is coming from. So here is our final answer for our antiderivative. We get x squared plus 4 to the 3/2 over 3 minus 4 square root of x squared plus 4 plus c. It's an interesting challenge problem. You might want to think about going back and trying to do this integral with a u substitution rather than a trig substitution, and see if you get the same antiderivative.